Hello, and welcome to this video from Dymedix Diagnostics. The purpose of this video is to demonstrate the technology and capabilities of the Dymedix TriplePlay Airflow Sensor. The TriplePlay Airflow Sensor detects 3 types of sleep-disordered breathing events, with only one sensor: apnea, hypopnea, and snore, thus the name TriplePlay. It incorporates PVDF technology, which makes it extremely sensitive, as it responds to changes in temperature, pressure, and vibration. It is designed to detect both oral and nasal breathing, and it is available in both adult and pediatric sizes. PVDF, or polyvinylidene fluoride, is a flexible film that creates measurable electrical energy when affected by either temperature change, pressure, or vibration, which makes it an ideal material for physiological sensors, particularly airflow sensors. The TriplePlay sensor design consists of an adhesive foam layer, a PVDF film layer, and a MAC-TAC fabric layer. The MAC-TAC and the adhesive layers absorb heat that is exhaled by patients during breathing, which adds to the sensor's sensitivity. And the use of the sensor adhesive is optional, which is helpful for patients with mustaches. The primary objective of this video is to demonstrate the performance of the TriplePlay Airflow Sensor during the following conditions: normal breathing, oral nasal breathing, hyperventilation, oral breathing only, nasal breathing only, an apnea episode, and finally, a dislodged sensor. In order to display the TriplePlay Airflow Sensor waveforms, we will be using a polysomnography or PSG device. PSG devices are typically used in sleep disorders testing laboratories and have many channels used to monitor a wide variety of physiological parameters. For our purposes, we will be using only one channel in order to display airflow. The amplifier settings we will be using are as follows. Sensitivity is set at 15 microvolts per millimeter. A high cut frequency filter of 15 Hz. A low cut frequency filter of 0.16 Hz. And we will not be using a 60 Hz notch filter. Here is a demonstration of the sensor being applied to the patient. Our first example is of normal breathing, which is primarily of nasal origin, with a normal respiratory rate. This is a typical sinusoidal airflow waveform, with an upward deflection representing inhalation, and a downward deflection representing exhalation. And here is a screen capture of the PSG software, providing a close-up of the airflow waveforms. The next example demonstrates oral nasal breathing. The patient's mouth is slightly open, and he is breathing at a normal respiratory rate. And here is a screen capture, providing a closer view. The next example is of hyperventilation. The patient will be breathing at a fast respiratory rate, and will be using both oral and nasal breathing. And once again, here is a screen capture of the waveforms. The next example will demonstrate oral breathing only. The patient will be wearing a nose clip, which will block all nasal breathing. And here is a waveform close-up. The next example will demonstrate nasal breathing only. The patient will be wearing a band-aid over his mouth, which will eliminate all oral breathing. And again, a close-up of the waveforms. The next example will demonstrate an apnea episode. The patient will take 3 normal breaths, and then upon exhalation, pause breathing for 10 seconds. And then resume normal breathing. And here is the waveform close-up. The next example will demonstrate the performance of the TriplePlay Airflow Sensor when the sensor becomes dislodged. The amplifier sensitivity was increased in this screen capture in order to increase the amplitude of the waveforms. This concludes the presentation of the capabilities of the TriplePlay Airflow Sensor. Thank you for watching this video from Dymedix Diagnostics.